Hello everyone. Thank you for joining us with the webinar on building AI-powered oil and gas copilots for data-driven decisions. This name may sound a little bit big, but we are going to talk about everything related to data in oil and gas industry. So we will be presenting the webinar. My co-host will be Vivek and Mayur. I would like to first go ahead and introduce the speakers of the webinar. I'll start with Vivek.
Thank you. Hello, everyone. I am Vivek. I am heading strategic partnership and alliances at CCTech. I have done my graduation in engineering and after post-graduation in advanced computing. I have done many projects in oil and gas, which involves the visualization of reservoir, then also using the data analysis for in-house oil recovery and so far. Thank you so much.
Thank you. So we'll now introduce Mayur. Hi, Mayur.
Hello, Subhransu. Hello, Vivek. I'm Mayur Pal. I'm currently professor at Kaunas University of Technology in the Department of Mathematical Modeling, which is in the Faculty of Mathematics and Natural Sciences, where I'm involved in mostly subsurface related research, part of which is also on AI and machine learning. Prior to being a professor at the university, I worked for oil and gas for nearly about 20 years. And in the last 5-7 years, was working on problems related to application of AI in oil and gas industry. And I will be talking a little bit about that in today's webinar later on. Thanks.
Thank you. I also introduce myself to you guys. I'm Subhransu. I am a mechanical engineer by my education, and I have been working with CCTech from last 11 years. And all these years, I have been developing core engineering software development from starting from mechanical, AEC, oil and gas, semiconductors. So I'm in love with mathematics more than anything else. So I like to develop softwares in mathematics and engineering aspect. So that's what I have been doing from last 11 years. And I'll briefly introduce what CCTech is before we go into the whole webinar. It won't be more than 2 slides. Then we'll get into the real topic of the webinar. A quick outline of what we will be learning or going through in this webinar. We will be talking about the oil and gas industry's data deluge, the term that we have been facing or we have been coming across around in oil and gas is a lot of data has been generated and how to deal with the data, how to make sense of it, how to make real powerful insights of it, how to make data-driven decisions out of it. So that's the main part of the webinar. And then we will see how data digitization roadmap looks like in this whole journey of making the data digitized and making insights, generating insights out of it and doing the data-driven decision making. And then we will also look at the possibilities or use cases or the type of applications that we can come up with by having a digitized version of data in this industry. And also the type of benefits it can show in the road going ahead. And we will also look at various demonstrations that will be a very big part of our webinar today. Exploring and expanding our understanding of what sort of solutions that is possible through data and AI. It's not just data, it's data and AI. And we'll also introduce at the end towards what CCTech is and what are the type of services CCTech offers in this domain in brief. And at the end, we will go through the question and answer sessions. So in brief, CCTech, I'll just give you some glimpse of it. We are a 17-year-old organization. We are based out of India. Our headquarters is in India. Today, we have offices in US, in Saudi Arabia. We have our partners in Dubai, and our development team mostly sits in India. What we are okay. I'll talk about our mission statement. What we do is what we love to do is we are a bunch of engineers or software developers coming from core branches mostly, and what we do is we love to um, take the software technology and democratize it, create applications, design solutions around it so that we can transform human life and bring that technology to the masses. That's what we love to do. And today what we are is it's a 17 years of journey to coming up with these stats and figures. We today are 200 plus software developers coming from, you say, design, simulations, machine learning, data engineering, computational geometry, cloud computing, HPC, augmented reality. So all the areas of engineering, the aspects of engineering from lots of core branches, all the core branches. We have people coming from all of these core branches joining us, and today we are of a strength with more than 200 plus engineers. So that's a glimpse of what CCTech is and been doing. We'll talk a lot about it later. But now I would request Mayur to please take on the presentation and let us understand what data deluge actually is in oil and gas.
Well, okay, all right. Thanks, Subhransu. Well, you see, when we talk about oil and gas industry, and it's a nice slide here, which gives you relatively all aspects of the industry from what is known as the upstream point of view, okay? Because oil and gas industry is basically related to producing oil and gas, as you see, and there's a lot of geoscience involved in this, which means how do you basically create geological realizations of oil and gas accumulation. And the figure here is just kind of a cross-section of an oil and gas reservoir, where you see some oil and gas accumulation, which has been targeted with help of some oil wells. And important aspect is that a lot of time these either are in onshore or offshore settings, which means under the sea or maybe on land. And a lot of these reservoirs are quite deep. So imagine something like you're targeting a reservoir which is 2 or 3 kilometers deep. It's almost like using a straw to drink a glass of, let's say, Coca-Cola, which is kept maybe 200-300 feet away, and you have to somehow put that straw at the right place, so that you can suck up all the oil and gas. So that's so there's a lot of moving parts there, just from the engineering point of view. How do you drill? How do you reach to those wells? Then the second figure shows more reservoir engineering aspects of it, which is more about oil and gas production. That, okay, once you have identified a reservoir, then what are the different mechanisms in which you can actually produce oil and gas? And the figure subsequently, the right one on is about drilling, which is more about how do you drill oil and gas wells, how do you do completions. Then once you have completed the wells, how do you produce? And once you have produced, how do you maintain the facilities? At each of these instances, a lot of data gets collected, For example, at the geoscience level, in exploration stage, you collect a lot of logs. Log data is used to create geological models. And when you're in the production stage, you're producing wells, then there's a lot of temperature data, pressure data, which is coming from the wellheads. Drilling itself is a large operation in which you have a lot of data coming from drilling, from the drilling mud, analysis of the drilling mud, from the analysis of the cuttings. Completions is another aspect where you complete a well, and then well completion sometimes can be very smart, so that you can have 24/7 data coming from the well bore. And facilities itself have a lot of sensors, which gives you pressure, temperature, and other kind of data. So in terms of data, the oil and gas, and not only this, sometimes oil and gas wells might be producing for 20, 30, 40 years. If you go in Romania, you have wells which have been producing for 100 years. So you have 100 years of data, and that's the amount of data you were talking about. And these data sets, you can also have sensor data coming from different plant facilities or even from the wellheads, which can give you at a very high frequency of 1 to 2 millisecond temperature and pressure data from wellheads. So if you start looking at the data from 20, 30, 40 years of production life, you are looking at really large amount of data that is being generated from different operation aspects of oil and gas industry. And all this data is now, available with the help of AI to actually create models to help improve understanding from the geoscience perspective, from the reservoir engineering perspective, from the drilling perspective, and also from operations perspective, which includes production operation and facilities maintenance, and especially in oil production platforms or even on onshore or offshore platforms. There's a lot of wear and tear over time, of equipments. So this data can also help us identify more kind of asset integrity issues. If there is some signs of some equipment being failing, then there's a lot of cost saving from that point of view as well. Because if you can already predict some equipment's failure, and then you can really optimize the plant maintenance and operation. Maintenance operations, because if there's an unplanned plant shutdown, then you are losing a lot of revenue because of this unplanned shutdown. So, but if you have a more planned, then you have with that. If you have more planned shutdown, then you can actually be more prepared for it, and that way things could be much better. Even from the just geoscience perspective, the softwares that are used by geoscientists for geological modeling or for reservoir engineering, these softwares are quite expensive, because and now there is a shift where a lot of engineers and geoscientists are trying that. Can they get away with the conventional way of modeling, but rather use the actual production data from the wells to basically help data tell us what kind of model should be there. So there's a lot of things. There's a lot of opportunities here. Relatively, people don't know much about it, and oil and gas industry also seem to be a little more conventional. But in the last few years, they are embracing AI and machine learning projects, and more things are happening in that front. That's all I will say, Subhransu, for now.
Great, thank you. Thanks a lot. So it was a very nice introduction of the type of data that has been generated in this industry from last 100 years. And on a daily basis, the data size is increasing, and lots of data is coming into this organizations who are looking after these reservoirs, and how to make sense of this data, how to really make real good insights of this data. That is something that we will be talking later. So I have a glimpse of the type of data that are available to the public internet. So it's not something that is specific to the organizations which have access to these reservoirs, but also we'll see. I have a small demo of how this data looks like. I'll present you that right away. Let me quickly open some demonstration of how it looks like. So this is, I'm opening a public government website from Texas, US. And this is a form which will give us all the public information around drilling permits of oil and gas industry. You all know that Texas is one of the largest production regions in oil production regions in the world. And if we see, I'll just submit without any filters, and we see that okay, there is no filters. Okay, all right. I'll quickly add all the districts of Texas and go for submit. I'll see something like 941,000 records found. Of course, that is more than what a website can display. So the website is asking me to refine my filter. The point that I'm presenting is, you see, almost 1 million records of data is found, or what we can say is drilling permit data. This is just permit data. Then we can go and see how many types of oil and gas information which is accessible publicly on public platform. You can see you have wellbore information, production data, we have permit data, we have completion data, and lots other type of data is presented. There are directional survey data and so on in this industry. So a lot of information is generated almost in a daily basis that we can see here. I'll quickly give you a glimpse of that. Let me just put approval date from date filter from something not very old. Let's just go with something which is a day before. So we are in Feb month and 28, 2024, and we'll keep it for today. Let's see how frequent this data is getting updated on this platform across the world. So these are, I'm just talking about public data. Public data is definitely way lesser than what data is generated in the organizations, in the oil reservoir organizations. We have 36 permits coming from Texas state yesterday. So how quickly data appears on the websites, on these portals, that gives us a sense that how frequently data is getting generated. So that's just a glimpse of that. And I'll go back to the presentation now and we'll see glimpse of how oil production data looks like. I'm just pulled out some stats type of picture here, and we can see the type of oil production data, and we have oil production data generally gets generated every hour. So from like Mayur said, this industry is operational from last 100 years, and in the 100 years, consider data recording is happening every hour, and we are logging this amount of data. This becomes one of the biggest data lakes in the world today. And how to make that sense of this data? That's the next part of our topic. So the basic version of data generally comes up and stores as files. That's what we all, it could be PDF files, it could be any sort of reports, it could be in those websites that I presented some time back. You will see that the data that we uh, sorry, the data that we saw, they are presented on the website, but then if you go ahead further into that website, navigate through them, you will get PDF files that can be downloadable. So majority of the data is hold or it's locked inside PDF files. It is also locked in some other type of data files. It could be Excel files, it could be CSV files. It could be, because this industry is very old, we have also experienced data being locked in COBOL files. You might have remembered COBOL might be operational in 1950s or 60s with those IBM mainframe machines, and we still have our government websites who upload data in COBOL files. I'm talking a lot about public data, but inside organizations also, inside oil and gas companies, there are data getting the primary format of data is files. And as we know, files data is more readable for human engineers or humans, not for computerized workflows. And hence, that's what I'm calling us as the primitive format of data, which is not so digitized. Even though the files are digital files, but still they are not so digitized. I'm skipping the step or the stage where the files and everything were physical in paper files. That used to happen before 1950s, and today, fortunately, we have all of them. I would like to say that today we might have all of them digitized in the form of scans or some other format. So I'll call this as the zeroth format or the basic format of files of data. This data is not very extendable because it is locked into millions of files across these organizations. Then comes the next layer of data, which is the unstructured data, which is nothing but, I'll give you an idea of the unstructured data here. If I go and open this website, you see it's a structured data. You can say that this is structured data, but you see there is no pattern in the data. The data is presented in the way the website designer wanted to design it. Or it could be if I extract all the text from a PDF file, then that data that it looks like that will be termed as unstructured data. So the main focus or the main point to understand here is in such kind of data, what you see is it's not highly utilizable by software programs because the data, if I extract all of this data into text, like something like this, or I can also copy the whole page and open Notepad and paste it. So you see everything comes into a single file. And this file is one single, it can have link, a text, it could have some file, PDF links, and it's a lots of paragraphs and lots of things. So here, if you want to query or want to extract the information like latitude, longitude, which is here, we can see that through our eyes, but for a computer program to extract this information that the GPS coordinate of this particular oil well is 32 degrees 17 minutes and 58 seconds. It's a tedious task for the computer or the program to do because it's a lot of text which is not structured in any way. So that's the challenge with unstructured data. Unstructured data is not highly usable by computer programs or automation. And if we are talking about AI, then definitely it's not much of a usability. Today, the scenario is changing thanks to OpenAI, thanks to all the large language models. We are able to make sense of unstructured data as well. But at any time frame of time, it's always better to have a structured data over unstructured data. Structured data, as we know, the greatest or the standard formats of structured data is Excel files. That's the universal standard for structured data. We all have been using Excel files. Um, if we want to go a step ahead into the computational programming journey, then beyond Excel, there are CSV, there are so many types of database, tabular database. SQL is the most famous one. And if we go beyond that into data science regime, then there are formats like PARQ formats and HD5 formats. So lots of structured formats for um, data which can be queryable for each and every single data independently. So that's where that type of data becomes more usable in nature. And then going a step ahead is once you have all the top layer is about data. The whole top layer the row we saw is about data. How data can be processed through software programs and it can be extracted from low level version to a higher and richer level format where querying is easier. Now, then, if we come towards how to use this data, how to bring or generate insights out of this data, that is the next layer, the second row. Here, what we know, what we can see is traditionally software programming used to happen in a more developers used to program the logic of the application and then the type of insights you want to extract out of any data, you can pre-code it and launch or publish a software which the consumers of that software or that analytics dashboard can consume that data. So this will give a fixed set of insights. So if you want to add more insights to these kinds of dashboards or analytics platforms, then you have to go back to your software developer and ask for to program those new logic that you want to be there. And then after some development time, those insights will also start appearing. So this is the standard way of uh, typical way in which fixed set of insights or the software programming used to work on top of this data. But today in this era of OpenAI, ChatGPT, LLM models. Today, we do not need to stick to some set of insights which are fixed in nature or static in nature. We can have real-time insight generation just by speaking to the application or by typing into the application. So that is the power that we are going to see today in this webinar, how this whole things work and what sort of use cases can be generated from this and what kind of benefits we can get out of this. So any questions anytime in this webinar you have, please write it down in the chat window. My colleague Vivek, he is uh, looking at your chats and he would be able to answer them any point of time. So just feel free to interrupt us. A little bit of technical aspect that I will be speaking now is how this whole magic happens of um, having data locked in any sort of basic file formats, and then from there how can we do a lot of intelligence based applications, the whole journey, how it happens, right? From the viewpoint of a software developer or a data scientist, let's see and understand how that whole journey works. It's a very straightforward journey. If you look at the if you understand the way that this process works, it's not that difficult, but it's a time consuming, tedious journey of verification and validation of the data. I'll go through that. I'll take you through that. So the first step is, of course, we have data in many sources. So extraction of data from the sources into our area of storage that we prefer to go with. So it could be files, the source could be files, the source could be some public data which is generated on the websites, or it could be the sensor data coming in from the physical world. So these are the sources of the data. These data comes, all this data come into, and we try to extract all of the information out of it in a low level format, of course, at the start. Then what we do is we move towards the next stage, which is the validation stage. As you know, if I'm, like I said, sensor data coming from the physical world. Imagine what would happen if the sensor has failed. And let's say we have a bottom head sensor, which is at the bottom of the oil well, which is like 10,000 feet below the earth surface. And that sensor was installed, let's say, some few years back, and it failed suddenly without any uh, without any of the indications, and we have been logging the incorrect or the empty data or the zero data from since the point that it failed, and our systems have been logging zero, or maybe it's just saying null values. So that information is being logged from last 6 months, and these all data is getting somehow is getting the real world data, that real pressure values at the bottom of the well is not getting sensed. And how do we get to know that? Because these wells, oil wells and all of these infrastructure in the field has lots of sensors, and all of the sensors, the health of the sensors and everything has to be periodically checked. But till the moment it's being identified, until the moment we have a opportunity to replace that well, that sensor on the bottom side of the well, it's a tedious process. It's a costly process. It's a tedious process. It may need sometimes the stopping of the production. So it's a complicated job, and hence we might end up having a lot of incorrect data being added into the system. And this is where validation is a very important role in any data engineer's life or journey, because if garbage or rubbish data comes into the system and it gets processed and gives some insights, you might end up with just some garbage out. Garbage in, garbage out. That's the terminology that this industry speaks a lot in open, because data is huge. It's very difficult to make sure the data is genuine, correct, and hence it's very important that the role of the data engineers comes into a very important role here, because they have a responsibility to make sure that the data that is being used to create insights, to generate insights, to make enable the leadership to take right decisions is based on the data that they supply to the system. So it is very important that we validate the data. Then comes the cleaning of the data. Then comes the transformation of the data. That is what means by cleaning and transformation is data might be logged in different unit systems. So you might need to normalize it to into maybe it's a temperature sensor. Then some sensor manufacturers would be logging data in Fahrenheit, some would be in Celsius. So if you have a common processing pipeline in the ahead of in the in the pipeline, if there is a logic which is common and expecting the data to be in Celsius, but the data appeared as Fahrenheit, then the whole calculations and the final results will be inaccurate. So it's again creating noise in the data. So it's very important that we understand, we first validate the data and we understand what data is being coming in, which unit system it is coming, what's the reference points, from which sensor it is coming, which manufacturer has created their sensors, and so what's the default settings for that data, and hence we transform that data. Then comes the enriching phase where you might be getting data which are primary information coming from sensors, from files, from logs, from websites, from any sources. But you might need to do some kind of mathematical operations on that data and derive some new properties out of it. Something very simple is uh, we can have ratios from of areas from sometimes it's a different types of derived properties are also needed in this whole it depends on what we are monitoring, what we want to visualize in our dashboards. It could be basic pressures and temperature values, or it could be some processing done on those, some mathematical processing done on those values, and then some new properties is what we want to look at. So that kind of information, from mass to volume, transformation using density to be multiplied or so on. So those kinds of mathematical operations are also needed, which falls in the enrichment process. Then this data has to be stored in some place which is safe, which is secured, uh, which can guarantee that it won't be lost after a lot of uh, in out of data. If we can make sure that the data will not corrupt, that data will not be get lost. So storing the data in a secured environment is what which is important. Then something that we call as orchestration. Basically what it means is the data size we are talking here is more than TBs of data, and the data is generating every hour. So all this data in this oil and gas industry, at this vast space in which it is getting generated, it has to be stored in such pattern that it can be then queried by any software which needs that access to that data without getting that overloaded of that huge data. Let's say, like I just showed you this example here, where what we did is we had more than almost 1 million records on this particular drilling permit for Texas, but this data has to be organized in such a way that the filters will work perfectly, and it can pull out those 36 results which is required. So orchestration of the data, the partitioning of the data, the way the data is needed by the end clients or the end consumers. So that has to be designed. So a lot of data engineering, data architecture, data structure designing people come into play here, and they design the right orchestration so that the data is accessible by all of the platform or modules that will consume this data in order to help the stakeholders take the right decisions. Then what comes into the next stage is monitoring of this data. So data, data means numbers. Most of the data is numbers, or maybe it could be classes, types, categories. So these are the only type of, these are two categories of data primitively. Now that data is if I say 1 TB of numbers, then those are huge numbers, and you cannot make sense of those numbers by just looking at the list of numbers on a table. So it has to be presented in a more graphical format, in a more abstracted format so that it can make sense to the human mind. So that is where monitoring, visualization of data is very important. So monitoring of this data, visualization of this data in the right format, which would make a lot of sense to us and from which we can have insights. That's very important. So that is a um, uh, activity which is it carries a lot of weightage. And at the last part of this is these are all the technical side, but then this data carries a lot of value. It carries a lot of power to drive industries altogether. So this has to be highly secured. This data is kind of the IP of this uh, organization also. So that has to be secured correctly. The data cannot be hacked. It cannot be leaking. So it has to have go through tight security and then also have the right governance. So governance could be at the organization level, governance could be at the country level, or it could be at the global industry level. So these are the aspects of data pipeline from the point of view or the from the glasses of a data engineer. So we data engineers have to go through all of this over and over again to make sure that we are not feeding incorrect data to the system. We are not breaking any security flaws or leaving out any loopholes so that the data can be extracted out and illegally being used for wrong reasons. So everything has to be taken care. So that's a huge amount of responsibility that we data engineers carry. Now, once the data is available, what comes next? So let's go ahead and understand that. I'll invite my colleague Vivek to present us with the wide areas of possibilities that we can do with this enriched data.
Yeah. Thank you, Subhransu, and thank you, Mayur, for giving the idea about different types and characteristics of data in oil and gas. And also, thank you, Subhransu, for explaining the what operations are needed on the data to make it usable. So let's talk about how we are going to use the data, what are the benefits, and what are the possibilities around it. So first thing is that dashboards and connectors. So you can imagine that your data is now available into the digital format. So you can use your daily drilling reports or your assets reports, your performance reports on a single dashboard, so that you can view their performance, analyze their performance, and if needed, drive actions from the data. So the dashboards and connectors will help you to do the data-driven decisions. So this is the first aspect of it. Then data intelligence from PDF. As Subhranshu also mentioned that there are many data is stored into the PDF formats. Not only in PDF formats, people are have also handwritten some notes on those PDFs. So to extract those information from the PDF, it is definitely a intelligent work. After extracting that data, you may directly filter out the data for from specific date to find out the event if anything is happen on that particular well on a particular day. What were the bottom hole pressures at particular day, because that data is in PDF. You can imagine if there are 50,000 of PDF and you want to find out one particular day incident, how that task is tedious. So making that data digitally available is definitely going to help the people. Then comes next the knowledge assistant. So when the data is digitized, then you will need something that you can talk with the data. So knowledge assistance is nothing but the you can directly query the data in your natural languages. You can ask the questions. It can integrate the data from different platform, understand it, and give you the results. So you don't have to understand on a particular day what well is working on that particular well, what sensor was established for on which machine. So these are the three different silos. But because of the knowledge assistant, you can segregate those data directly into one and ask the question. Then comes the enhanced oil recalling. You may know that EOR is a methodology in which you can increase the oil prediction But this whole methodology is depending on your WAC cycles, how you are going to operate your injection well so that you can improve your performance on the production wells. So all this can be possible to simulate using the data on different scenarios. Like you can try alternating gas, you can try directly WAC, you can even change the frequency of like 3 months of water injection, 3 months of gas injection, then 6 months of water injection, 3 months of gas injection to analyze how the production is going to change. Then comes the hot topic in today's era about the digital teams. So you can directly monitor your wells in a digital format, also check how the production is happening, check the well levels, how the data is associated with them from different platforms on a visualization basis. Also, digital twins will help you to do the what if scenarios, like what if some well is broken, what if some sensor is not working, what if some oil production is dropped. So these kind of scenarios can be um, performed using the digital twins. And the last one is the physics informed neural network. So until now we were talking about the data and AI, but this is the thing where we will join the physics or science with the AI on the data, because this will give you the more accuracy in your operations, because it is going to be supported by the physics neural engines. I think now let's move ahead and let's see how the demo about these benefits or possibilities. Over to you, Subhransu.
Yes, in fact, I would request Mayur, if you are still with us, to give us a quick overview of this excellent application and Dialytics, what this application provides and what is it meant for and who is it meant for and what sort of use cases that it solves. Are
Okay,
you?
sure. Yeah. So, well, thanks, Vivek, for giving a bit of an application side of where we can use all the machine learning and artificial intelligence on the data from oil and gas industry. So, as Subhransu just said, we have actually created an application, Dialytics, which basically stands more for data analytics kind of, but applied to more oil and gas. I think, can I share? I can share my screen. Yes. Can I share my screen now? Yes. Okay. Can you see my screen?
Yes, it's visible.
Okay. So there are two before I go into this one. This tool specifically deals with some aspects of the data which is used in oil and gas, and it relates more to some of the applications which Vivek spoke about. So we have, in fact, a brochure. So it's mostly about reservoir simulation and analytics related to that. So there is an aspect of PBT, which is, if you remember from your high school physics, it's pressure phase. I mean, PV equals to nRT is a classical equation everybody knows. So it's about phase behavior of oil and gas, both in subsurface and on surface. Then it's about then we have tools which can help you to model this. There are tools to model primary recovery. With the tools for modeling enhanced oil recovery and doing screening, decline curve analysis. These are some aspects of oil and gas production. Then there are also tools available for looking at petrophysical properties like relative permeability, capillary pressure, and all. And then there's also AI-based solutions for forecasting and history matching. And similarly for looking at secondary recovery, which Vivek spoke about, also known as enhanced oil recovery. So these are, and there are a number of different benefits, because all the tools that we are going to show, they basically link with different aspects of oil and gas, and we have tried to use machine learning and bring all these different tools into one single platform, because oil and gas industry uses different softwares for different aspects. And what we have tried to do is bring it all together on one platform. And so these are, again, different aspects. I mean, there's a lot of detail in these brochures. So we can do economic analysis. We can do, we have a very powerful database. And there's decline curve and forecasting options as well, history matching and forecasting. These are different kind of things that you can do with oil and gas data. So coming to the tool itself, so it's a cloud-based tool, and once you log into this platform, then you are presented with a number of different modules which do different kind of things. For example, you have your reservoir input properties, where you can basically do a lot of benchmarking of your reservoir, plus also you can create your cases that you would like to analyze in all different other modules. There is a database. So database is a very comprehensive database, which has data from about 2,000 reservoirs, which have been meticulously collected by engineers, QA/QC. PVT modeling, which I spoke about, is again another tool, and relative probability, which is more for petrophysical modeling. Then DICE DCA is a decline curve analysis, which helps you to forecast in coming years and months the amount of oil, water, gas will be produced. Material balance is another kind of model which is used for modeling and simulation work using simplistic tank models. Then we have EOR IOR screening, which is based on machine learning and physics based as well as machine learning based. And then you have recovery factor analysis, which is again an optimization method looking at what is ultimate recovery from reservoir. There's also DICE economics, which helps you to do economic evaluation of your project. And then we have also developed a capacitance resistance model, and then you have machine learning based history matching and forecasting, and probabilistic DCA, which is again an approach for decline curve analysis using probabilistic methodology. I'll just showcase some of them because there are many of these modules. So let me just show you a quick data related our database, which is collected from papers which have been published by SPE over the last 20-30 years. So here, basically, the idea is that you can use it for different purposes. You can use it for doing PVT analysis, but you can also use it for just benchmarking your, let's say, oil and gas reservoirs. Okay, so if I can just show you, so it's taking some time to load, but I can choose a region, for example. Okay, what's going on? Yeah. So it shows up now. So let's say if I would like to look at some specific thing about, let's say, in Europe. So I'll choose my region as Europe. And then let's say I'm looking at Norway as a country. Okay. Then I will start seeing all the different reservoir related data that is publicly available that I can actually use for my benchmarking. Here we are mostly talking about enhanced oil recovery, but I can also go to other countries as well, and I can look at these features. But also in the same tool, I can also go and look at PVT. So the tool has two objectives. You can basically do benchmarking. Let's say you have your own reservoir data, you can benchmark. How does my reservoir data looks compared to other reservoirs of similar types around the world? Other aspect that you could do is also that if you do not have data, then you can use other reservoirs from around the world with some of the data available to figure out what other data can be used in your project. And same is true for all reservoir properties, so you have you can look at water saturation, you can look at viscosity, pressure, porosity, and a lot of different correlations you can develop. So that's the idea of the dashboarding tool. Then I mean, I can also show you maybe a bit of history matching and forecasting aspect. So basically, I hope this will work without. So if I let me say, if I open a project, oh, I don't have one. Sorry here. let me go back. Sorry, let me go choose another one. For example, if I choose here maybe an algebra recovery screening with machine learning, so I have different modules here which can do physics-based screening, but also machine learning-based screening. So I can actually put reservoir properties, or these can be populated from the project data that I have initially put at the input stage. And then if I with this I can screen the reservoir, and then it gives me an idea of what kind of EOR technique can actually be used here. Okay. And I can do both physics-based and machine learning-based screening here, or I can use a combination of physics-based or machine learning-based screening too. So, and there are many other modules, like if you would like to look at chemical recovery, if you want to look at water flood, those all things can also be done here, or water alternating gas, a lot of other tertiary recovery aspects you can explore too. And let me also show some quick other aspects, like for example for PVT. So for PVT modeling, you can actually here some default data, so I can actually run PVT simulations online here on the cloud, and once I run the PVT simulation, then I'm able to actually look at oil and gas phase behavior for this particular, let's say, oil, water, gas, or if I want to look at composition predictor, which is another something that you use in modeling, you can do those kind of analysis as well from this tool. And the thing is here that you can also use the data which is available in the database for different which has been collected over for 2,000 reservoirs for your work, or you can actually even go to the journal data input, which is more your let's say you're working on a specific reservoir, you have some data for this reservoir, so you can actually fill in that data and actually use that data throughout these different modules as well. So let me just quickly show you this one. So here actually, of course you can change these values, but I have put a journal input, so I can save this input as of different aspects of the reservoir data, let's say. And sometimes this data is usually collected by the companies or the research institutions. And if I save this data, then it's available for me to analyze on all different modules that I have. And what else? Of course, there is capsaicin resistance modeling and machine learning. I wanted to show you the machine learning one. Let me see if I could actually figure out. Yes, so let's see if I download Excel or choose one. Sorry. One projects. I will have to create a project, so it might take a little bit more time. But let me see if it will work. If I try to do it, no, I need to select data. So download Excel file. Let me see if the file is downloaded here. Okay, no, I will have to, one second, maybe the file was there. Sorry. Yes, I do have the data here in this file. So let me import this. So let me choose this file. Come on. 1 second, let me refresh. Okay, downloaded files. Import. Okay, so I hope it will work in reasonable time. So, well, you need to prepare all that data. So, for example, I was just showing you while it does this. This is actually a data file which has which has actually well data. So here there is some well data. You could see the time here from starting from 1997, going all the way to 2020, and you have a lot of different data entries here. So this is a huge amount of data which has been curated and prepared for this particular work. And in this one, you have, a lot of different things: daily water rate, oil rate, pressure, temperature. And what do you have it? All the different sensor data that is available from a wellhead is all captured here, okay? And this can be used once you have, it's taking some time to load this. Maybe I should have prepared the project before. But once the data is loaded, so then you can use, looks like the data is loaded. So you can use it for history matching, and also you can use the same data for forecasting. So now what the machine learning model is doing is that it's looking at all that well data and trying to create a history match model. These models are typically created using very expensive softwares like Eclipse and Petrel, but here we are doing it with help of injection production data, which is available from the well, and creating a history match model. And once the history match model is prepared, you can actually then use it for future forecasting as well. So where you can forecast this for a couple of years or a couple of months, depending upon your need. Again, it might take some time. It's running in the background, a machine learning algorithm, which is based on some sort of LSTM type model. We, in fact, have published a paper on this. If somebody's interested, they can reach out to Subhransu, and we can. So here now you see that it just plotted it. So we have created so the dots are actually the actual data, and then it also shows how much what has been used for training, and then a model has been prepared. And this model then we can use for actually forecasting. If we want to do some forecasting, then the forecasting can also be done on this for a couple of years, a couple of months. And you can choose that how long you want to do the forecast, and stuff like that. So I think this is, and you get some other metrics like the model parameter training and other aspects. So if somebody wants, we can provide more information. We can share the brochure. How does this thing work? And we take it from there. So I guess, and if anybody has any questions, of course, also more than welcome to ask. So Subhransu, I think that should be okay. So here you can see now I've created a very long forecast, maybe an unreasonable forecast here for about 20 next years, because I did it very quickly. So the green line is actually my forecasting model. Of course, the match is not so well. I need to work a little bit better on constraining this model. But it gives you an idea that such kind of things are also possible. So I think that's about it from my side, Subhransu, unless somebody has a question.
Yes. Thank you, Mayur. Thank you. It was an amazing presentation, amazing demo of the application. Honestly speaking, the type of the concept of this application, like bringing the data, the physics, and the global data, the generic data that is public data that is available about the reservoirs around the world, and the historical data of our own reservoir, bringing it into the same platform in one single place, and doing all this type of predictions analysis for 20 years in the future. That's amazing platform that has been developed here. So I'll move ahead quickly because of time constraint. We are already past the 1 hour mark. But I'd request people, if anyone has some commitments ahead in their day and want to leave the webinar, please feel free to just write us and let us know about what we on this. Any questions you have, you can write to me on the LinkedIn. You can ask me anything, and I would be happy to share the presentation, the webinar, the webinar video on YouTube, the links to that and everything. So if you miss out today, then we'll be there. It will be there in the YouTube video. So If anyone wishes has some commitments, please go ahead. I will continue for a few more minutes before we end the session. There are a few more slides to our presentation. We'll talk about a little bit on the work around the type of AI models, what AI models connected with physics can do in ER optimization and few other projects that we have worked to understand how is useful. I'll go through them and see. Like we see, part of the presentation was done by Mayur in the software. He shared the whole concept of how predictions happen from data and the history matching model, how it learns first from the looking at the history and then how it creates a model which can then predict the future based on the type of inputs we want to provide to the reservoir so that the production is optimized. So those kinds of with those kinds of inputs, you are able to create a model through something called as physics informed neural networks. That is something that is state of the art, and with that we are able to uh, go ahead in time and predict how how we can maximize the production of the oil by minimizing the impact on the environment. So that's what we are able to do with these type of technologies, advanced technologies that are coming up together today, and the type of accuracies that you can achieve through these type of technologies when implemented correctly is it's a graph of the type of matching you can see. So this is a real research work that has been done here, and we can see the type of results and matching that we see here. It's like uh, it's like 90% or 70%, 70 to 90% accuracy that we see here. Coming from a long background of oil and gas industry, I can tell this that if we go with traditional simulation approach, we might be achieving something. The prediction accuracy could be around 30 to 50%. Then from that, using just machine learning approach, we may increase that to 60, 70%. But through using of physics plus machine learning and plus historical data together, all this, the combination of all the three can give us a prediction of 90% accuracy. And what we are talking here is not a simple physics. It's the one of the most complicated physics happening under our Earth's crust, under our Earth's surface, inside tens of thousands of feet and beneath us. And the type of physics is pretty much complex here, and we are able to predict that for next 30 to 20 to 30 years in future is something that is incredible. So the power of data and data science is something that is really being presented here. I'll go to the other aspect of data science here, where the data is technology is not used to predict or identify the right approach to increase the oil production with the minimum impact on the planet. Beyond that, we will talk about how we can use intelligence or AI to use to apply to the data which is locked in PDF files largely, because what we know is 70 to 75% of our data is now today locked in PDF files. It may be generated from Excel files or it may be generated from Word files. This could be um, invoices, this could be reports, this could be surveys, or it could be lots of other things, but all of them, they sit in the end, they sit in PDF files, and the source files, they might be lost in the course of time. So what we have is PDF files, and extracting information from PDF is very tedious, and once that is extracted, there are lots of losses, and then the data that comes out, it's very difficult to query that data. It's very difficult to ask for insights from that data. So that's what we'll see the power here. Um, so the PDF files will be the input to such a system, and what AI engines will do is it can extract information 100x faster than a manual method of data entry, and it can generate data which is more structured in nature. It could be SQL, it could be Excel, it could be JSON formats, and this data can then be used to query a lot of insights out of that data. A very small example of that is if you have a PDF of a drilling report on the left that you see here, contains tables on the bottom side of the part of the page, and it has key value type of the label and its value, label and its value, that kind of a information on the top. And all this information can be extracted. Uh, the technology is not a new technology. We always had text extraction from, you may ask that text extraction is present from last 20 years. So what's new is been happening here. So text extraction is one part, but when you extract text, you get individual pieces of text as just simple text. And how do you make sense which is connected, which is a label, which is a value, which label is connected to which value? Because it's all unsorted, it's all loses all its context. So preserving the context or relearning the context and making sense of the numbers that we are extracting here is very, very essential. So that is where the new AI technologies help to extract form type of data or table type of data, where you have every information correctly identified of what it is connected to, which column it is from, or um, what type of label it is coming from. So all this type of information is extracted accurately through these type of systems. And what next we can do with this digitized data? You cannot ask the system to go read a PDF and give me all the insights. Like here in the example, you can see that there is a column called as PT and PT. PT means productive time, and NPT is non-productive time, which means it's a drilling report, right? In a drilling report, what you get is there are the oil wells are being drilled by a contractor, and what happens is uh, it's a daily drilling report. So we have report for 24 hours, and what happens is for every operation that is being taken from some time to some end time, we have a duration and what was the record, in this duration what happened, whether that was a productive time where the drilling was happening or there was a breakdown time. So non-productive time, maybe the machine broke down, maybe there was some other issue in that region for which the drilling was not done. So I'm just giving you an example of the use case where if such kind of data is present in your Excel files, in your PDF files, then you can create some such kinds of assistants where you can just ask naturally. Um, yeah, you can ask in a natural language, just type like you type in chatbots, and what happens is the AI engine behind extracts all the information. So there was a question asked to give us all the daily drilling reports from for 1 week of a duration. So it extracted all the PDF files, and then what we did is we are asking find the contractor which where total non-productive time is exceeding 20%. So in a day, 20% of time is non-productive. So that is a huge amount of loss of time for in this industry. So this system is able to give us the identifiers which contractor and which particular well and which particular day the productive non-productive time was more than 20%. Then we can open the report and find more information out of it, or we can keep on continuously querying beyond it. So that's the type of intelligence that can be built just from PDF files. So that's the power that AI has today, and it is all productionized. What we are showing is not something POC or something. This is being something being developed from last 5 years for oil and gas major, and it's all uh, in production, in use by the industry. So I'll quickly move towards the other part where we saw at the start of our webinar, there was websites which publish public data about natural reserves, mostly oil and gas reserves. And um, how do you, there's a lot of data and we cannot visit every natural resource website and extract every form's data. And this data is updating every day. We saw that 36 drilling permits were being awarded yesterday in Texas. That's what we saw in the first part of our webinar, and how to extract all this data and create intelligence out of it. So it was just one state's in one US state website, and there are so many around the globe. Middle East itself has the biggest oil reserves in the world, and you can understand how much of the data that is present there. And so, creating solutions which can autonomously go visit these websites, extract the data that is required. It has to be also computationally not that expensive and not burdening to the website servers or the infrastructure, so that the resources are not able to handle. So it has to be lightweight. It cannot be um, spamming, or it could not be extracting a lot of information again and again. So it has to be cognizant of what information is new to the website and then extract that only. So imagine creating such a solution where 350 plus sources of data is being scanned daily, with more than 50 million plus lines of data is extracted from these sources, and the delivery of this data after being processed and enriched is just 1 day. uh, this was a project that we did almost from last 5 years, and before this transformation, the time taken to deliver data to the customers, the end customers of this organization, was 90 days, and the target was to come down to single day. So it needs scanning of data from the sources, extraction of data. Everything has to be automatic. The validation of data, the cleaning of data, the transformation of data, and the loading of data into the databases, which then opens up in the customer's mobile applications or web browser applications. So that journey, you can see the amount of data being extracted and the frequency of just, I think, 1 month of a snapshot is what we see. We also talked about the digital twin of the data. Once the data is extracted, let's say the directional survey data contains the shape of the wells and everything done through sensors being inserted into the wells, and these reports are being made available to the public and also to the organizations which own those lease those wells. And this is important to have created digital twin, which gives the visualization of the whole oil reserves, and the flat surfaces that you see here are the oil reserves, and then the wells, you can also always understand the wells are going down and then turning horizontal, so that it enters the oil reservoirs, and that's where the oil extraction happens. So visualizing these wells in 3D, and then having interfaces which can do all the analytics, like what is the nearest neighbor of this well, and how far is the nearest neighbor, and how much density of oil wells are in this region, so I can identify, field planning can happen more effectively. So that is the type of use cases that can be done through um, enriching data. Um, um, Oil and gas industry depends a lot on valves, industrial valves. The whole downstream has a lot of oil flow happening, crude oil being processed into processed oil and all. So the valve industry is a very critical one in contributing to the success of oil and gas industry. And how data can be used, or data and AI can be used to designing the right valves to make sure that the oil processes require the valves are designed in the right way the oil industry requires it. So that's what something can also be, it was also done by CCTech, some, I guess, 5 to 6 years back. This was a very crucial application that we developed, and it's one of its kind in the industry. And we were the first one to design or create a AI-based valve designing application, where you can see in this present in this uh, snapshot that you can just design a valve with just few parameters. Here we can see just 4 parameters, and the whole valve's performance can be predicted, and the shape of the geometry of the valve can be designed in real time, and you can download it and then go for production. So it's a something that is present available on the on Systex website, and yeah. So I'll quickly move to the end of the presentation due to the time constraint, and Vivek to quickly present us a few slides around what CCTech is and what sort of offerings CCTech has, and if any one of you are interested to explore any challenges that you have in your workflows, then we would be happy to listen to your use cases and also collaborate with you.
Sure. Thank you, Subhransu, for giving the brief idea about the workflows in the oil and gas industry. Is my screen visible?
Yes, because
Okay, thank you. So, uh, to talk about the CCTech, we are the partners with Autodesk, AWS, Azure, NVIDIA, Bentley, and AMD. So, in the CAD side, we are partner with Autodesk and Bentley. On the cloud side, we are partner with Amazon and Azure. And for high performance computing, we are partners with the AMD and NVIDIA. Let's talk about our partnership with the Autodesk. So we are development partner, offshore development partner with the Autodesk. So we are directly working with large number of products with the Autodesk to develop these features for them. This includes all verticals of AutoCAD, Revit, then data exchanges, Inventor, Fusion, and also those are in across the globe in the different countries. Then let's to talk about the journey of the Systech. So we have started working from 2006 and until now we have been in the industry for 18 years. So we started our journey as a CAD and CFD development, then we entered into AEC. Then from last 12 years, we are working in the oil and gas and energy, where we have developed solutions for data analytics, discrete fracture networks, and also uh, data extraction platforms. Then we also started our work in ML in 3D. Then recently we also started working in semiconductor industry, and now we are also uh, uh, working into the hardware acceleration part. So to talk about the how the CCTech is distributed. So we have two divisions. One is the product and one is the consultancy. So we do have a product called a simulation hub, which is the one of its kind into the world and first cloud-based CFD platform in where you can do the CFD automatically by just providing your geometry. So all the automation has been done on the cloud. And then on the consultancy side, we do directly work with the enterprise clients to develop the customized solutions for them. In that, we have worked with the Fortune 10 plus Fortune 500 companies. Then to talk about the industry verticals, we are majorly working into the architectural, engineering and construction, oil and gas, manufacturing, and semiconductor fabrication verticals. These are the just glimpses of our clients with whom we have worked. So in the oil and gas sector, we have done work with the Shell, Halliburton, Maersk, North Oil Corporation, Indian Oil, and so far. Then to talk about the oil and gas projects, we have done a discrete fracture network visualization project with Shell and Maersk. The project was involved to create a mesh for a petrol application in an effective and optimized way. Then physics plus AI UR optimization for North Oil Company, data engineering for data lake for Halliburton, USA, data sourcing platform for Wood Mackenzie. Then we also done some work into the renewable energy sector or power plant sector in which we have done work with the GE Power. Also, we have done some digital twin with the Bentley system. Then to talk about our offerings, we do have offerings in the history match forecasting, design optimization for either those are for walls or any kind of manufacturing. Then data dashboard to visualize your data and also get the insights from it. Then data intelligence from files. We are able to extract the data from files. Then AI solution, discrete structure network, data sourcing platform, CDA and connector. So CD is nothing but the common data environment where you can integrate all the data from different platform, including SCADA, then sensor data in a single platform. Thank you.
Thank you, Vivek. Thank you, everyone. Thank you all for joining this webinar. I know it was a long webinar. I think it's almost consumed our 1.5 hours. I'll uh, like to thank Mayur for spending time and giving us time for this webinar.
Thanks for inviting me, Subhransu, and thanks Vivek for a nice overview.